Welcome to the deep dive. Today we're getting into planted aquariums, specifically that big question, which plants really need extra CO2 and which ones are, fine without it.
Exactly.
Yeah.
We're looking at some notes from a fish keeper. Someone who's actually done this, watched their plants, and checked their findings.
Yeah, real hands-on stuff. So our aim here is pretty simple. Help you figure out plant choices without maybe overcomplicating things with CO2 systems if you don't need them.
Let's clear things up so your plants can really flourish.
Okay, so let's start with the basics. The source, our fishkeeper friend, sort of learned this simple rule first. Submerged plants need CO2, floating plants don't. Sound about right.
But yeah, that's the starting point, and it holds pretty true for the floating ones. The source mentions Salvinia, duckweed, water sprite, those kinds of things.
Ah, the floaters. Yeah.
And notes how well they do, even in outdoor ponds. It makes sense because they can just grab CO2 straight from the air, right?
Yeah.
Way more available up there.
Right, direct access, no need for fancy injection systems when you're literally touching the atmosphere.
Exactly. They're basically breathing air.
Okay, that part seems clear. But the submerged plant role, that's not the whole picture, is it?
No, definitely not. And this is where it gets interesting. The blog points out a big exception. These slow-growing epiphytes.
Epiphytes. These
Yeah.
are the ones that attach to things.
Yeah, typically you see them on wood or rocks, not planted down in the gravel or sand. And that lifestyle kind of links to them needing less CO2.
Okay, and we're talking about really common ones here.
Oh, yeah. The classics. Anubias and Java Fern are the main examples given. You see them everywhere.
Right, I know those. So why? Why are they different from other submerged plants?
Well, the source suggests it's down to their leaves, mainly. They often have these larger, tougher leaves.
Okay.
And that larger surface area lets them be more efficient at capturing the CO2 that's naturally dissolved in the water already, even if levels are low.
So they're just better adapted to soak up what's available.
Seems like it. It's not just the size, probably also their, slower metabolism. They're not growing super fast, so their demand isn't as high as some other submerged plants.
Makes sense. Slow and steady. Did the blog mention anything else about them? Nutrients, maybe?
It did, yeah. It points out they can also absorb nutrients directly through their leaves from the water column.
Ah, so they're not just relying on roots in the substrate.
Exactly, which again helps them thrive even if the water isn't, packed with dissolved CO2 and nutrients.
Yeah.
They're pretty self-sufficient in that regard.
Okay, so let's pull this together. If you're looking for plants that generally don't need extra CO2 pumped in, you've got category 1, the floating plants,
Like duckweed, salvinia, yep.
and category 2, these specific submerged ones, the slow-growing epiphytes like Anubias and Java Fern,
Precisely. Those are the two key groups highlighted in the source.
which is really useful information, right? If you're setting up a tank, maybe a low-tech one, or you just want to keep things simpler.
Absolutely. Knowing you can have beautiful, healthy plants like Anubias, or let some water sprite float on top without messing with CO2 canisters and diffusers, that's a great starting point. Makes planted tanks feel much more accessible.
Okay, great. So quick recap then. Floaters grab CO2 from the air, easy peasy.
Yep.
And then these particular submerged plants, the slow growers, the epiphytes, they're just really efficient with their big leaves at using the CO2 that's already in the water.
That's the core takeaway.
Uh-huh.
But, it does make you think.
Uh-huh.
Even for these plants that don't strictly need the added CO2, how much does the rest of the environment matter? I mean, the blog focused on CO2, but what about, say, lighting or water flow?
Oh, right. Like, could an Anubias still struggle in a really low-light tank even if it doesn't need extra CO2? Or maybe too much flow stresses it?
Exactly. So something for you to consider is how these easy plants might still react to different conditions. Is just avoiding CO2 injection enough? Or do you still need to balance those other factors depending on your specific setup, whether it's super low tech or something else? It's rarely just one thing in an aquarium, is it?